Okay, so in the previous video, we've seen how to draw a derivative function of a given function. So in this video, I'll start by taking a random function. So this is no specific function, but just a random graph. Okay, so I just choose a random graph here, and so I hope you're all familiar with the concept of average rate of change and instantaneous rate of change. So I'll just quickly go over what the two are. So average rate of change is, let's say, so average rate of change is between two intervals. Okay, so let's say this is the velocity line graph of some object moving. Okay, so here I'm plotting the time and here I'm plotting velocity. Okay, sorry, I'm plotting the distance versus time graph. So this is a dt graph of some object moving. So the average rate of change here means the average velocity from some point to some other point in time. So let's say we choose two points in time, this and this. So let this be A, let this be B. Okay, now how do I find the average velocity? Well, I hope you all know this. You might have studied this earlier also. So I take the position at time A and I take the position at time B here, and this is the total change in the distance. Okay, so this is the total change in the position of the object, and this here difference, so that is delta d there, change in distance, and this is delta t, change in time. And if I divide delta d by delta t, what I get is the average velocity. Okay, yeah, so that is the simple concept of average rate of change. So velocity is the rate of change of position with respect to time. So that is the same case in other graphs also. If I have an if I have an xy graph, yx graph, so there the change in y divided by the change in x, the total change in y divided by the total change in x gives me the average rate of change. What is instantaneous rate of change? So instantaneous rate of change is actually calculated at a single point. So let's say what is the velocity at this point in time. So how do I find that? So there I don't take an interval, and obviously I've covered this in a previous video also, but I'll just give you a brief here also. So what is instantaneous rate of change? So instantaneous rate of change is simply the velocity at a single point. So when you're driving a car, what the speedometer shows you is the instantaneous rate of change or an instantaneous velocity. And how do we calculate that graphically? Well, I take the point and draw a tangent. I draw a tangent to that point, and that should be somewhat like this. So that is my tangent to this point at this point. Okay, so this is some point, let's say A, and if I find the slope of this tangent, that will be my instantaneous velocity, or generally instantaneous rate of change. Okay, so that is those are the two concepts. Now instantaneous rate of change is actually just a number, right? Just like velocity is after all a number. So it is a number associated with a single point. So let's say at this point we had some velocity, some rate of change. Okay, so that is a number associated with this point. Also that one. Okay, so that is so that rate of change is also called slope, right? Or the derivative at that point. So that is a number linked to that single point. So now let us take a general case. So wait, I'll just redraw this quickly. So I'll stick to the same graph. Okay, so let us take two intervals A and B here. So this is my x-axis, this is my y-axis again. So this is a general case here, and if I have to find the average rate of change from this point to this point, how do I do that? So one way was actually to take the total change in y and the total change in x, divide the two, and get my average rate of change. So that is one way, delta y by delta x. Okay, average gives me average rate of change. Okay, so I'll just write. Okay, leave that. Gives me average rate of change. Okay, so the second way I can do is, so what does average mean after all? It average means adding up some values and then dividing by the total number of values taken. And average rate of change means adding up all the instantaneous rates of changes from this point to this point and dividing by the total number of points taken. So how do we do that? Let's say I take this point. So at this point I draw a tangent. So the tangent will be somewhat like this, okay? I find the slope of this, which is a number. So I take that, I write that somewhere, okay? Then I take the next point, okay? And then I make a tangent at that point, find the slope, add that there, okay? And I do that for as many points as possible from this point to this point, okay? So I do it for all these points, as many points as I can cover, and simply add all those slopes, all the values of slopes, I add them together and divide by the total number of points that I've taken from this point to this point. And what I end up getting is the average rate of change from this point to this point, okay? Because that is how we just found average, right? And that gives me average rate of change by adding all the rates of change from instantaneous rates of change from here to here and dividing by the total number of points taken. So this is simple. So how do I write it? So the second way is adding slopes at various points, and then okay, so dividing this whole thing by, and then dividing this by, I'll just write it in short, dividing by total number of points taken. Sorry for the handwriting. Yeah, so these are the two ways in which you can find the average rate of change. So I want you to note these two ways down somewhere and keep them in your mind, because we'll be using this in the next few videos, okay? So this concept. So that's it for this video, and we'll meet in the next video with and continue the discussion on integration, okay? Bye.